Finding roots of polynomials, as you know, is one of the fundamental questions in polynomial algebra. As a matter of fact, what does the quadratic formula really give us? The values of the roots of the polynomial. So, for example, if I looked at a quadratic equation and set it equal to 0, you're looking for the values of x which make that polynomial expression equal to 0. The problem is much harder when polynomials are of degree greater than 2. If you're looking for values of x which make this equal to 0, that is a more difficult problem, but still an important one. Whether it's a polynomial of degree 3, a degree 4, or degree whatever. You'll notice this one process tells us if I choose, in particular, a value of a such that a is a root of the polynomial. I think I can take this away now. If f of a equals 0, and that's very important. That's like finding the roots of a quadratic equation using the quadratic formula. If f of a equals 0, then that means that f of x looks like x minus a times g of x plus r of x, which equals 0. Right? If f of a equals 0, r of x equals f of a, so r of x is 0. And that means that you can write f of x as x minus a times g of x if f of a equals 0. One of the things this means is that, say, I begin with a polynomial of degree 3 here. If I can find any value of x which makes this equal to 0, then I can write this polynomial of degree 3 as x minus a times g of x. This is a polynomial of degree 1. This is a polynomial of degree 3. So this is a polynomial of degree 2. So if I can find one root of a polynomial of degree 3, it factors like this. And then I can use the quadratic equation, if necessary, to find other roots of that polynomial of degree 3. Okay? And so, let me choose an example, at least one more. I may adjust this a little bit so I can tell what this one answer is. So here's a polynomial of degree 3. All right. I did an easy one. What are the roots, if any, of this polynomial of degree 3? I did it in such a way that I could recognize one root easily, right? What is one root of this equation? X equals 1. Notice f of 1 is 0. You agree? F of 1 equals 0. Replace x by 1 and you get 1 cubed, which is 1 plus 2 times 1 squared minus 3. It's 0. Right?
What's a root? What do you mean by root?
Exactly this. A value of x which makes the expression equal to 0. That if you're talking about a quadratic equation, for example, the graph of a quadratic equation looks like a parabola. So this might be our choice of what the parabola looks like. The roots of this parabola are values of x which make it equal to 0. If I have an expression for this parabola, I'll use a quadratic formula if necessary, if I can't factor it or some other technique, in order to find out what the values of a are that make this equal to 0. Okay?
So you put 1 in for x and then it becomes 0. And that's why it's the root.
Yes. So, since that's the case, that means if I divide x minus 1 into x cubed plus 2x squared minus 3, what will happen? You'll get a 0 remainder, right? Because the remainder is the value of the function at 1. So if I divide this, I'll get a 0 remainder. So use x squared here. This is x cubed minus x squared. And then we subtract this particular term. This is 0. Changing the sign, this is 3x squared minus 3. Right? And then if we do plus 3 here, plus 3x. Let's see. Do this right again. 3x squared minus 3. X cubed minus x squared. Right. So I get 3x squared minus 3. Yeah. This is plus 3x. This is, I'm not done yet. So 3x squared. Let me stretch this out a little bit. Bringing it down there is fine, but I don't need to. And this is plus 3x. And subtract.
Minus
3x.
Minus 3x.
What's your name?
Yes. Change the sign and you get 3x minus 3. And then it's plus 3. Plus 3 gives us 3x minus 3. Sorry if that's so low. Can you see all of that?
No.
Do you want me to do it over here in a higher position? That thing kind of gets in the way. Let me do it here. This is x minus 1 times x cubed minus plus 2x squared minus 3. And so this is x squared, x cubed minus x squared. Change the sign, this is 3x squared minus 3. And multiplying by plus 3x squared minus 3x. Change the sign and subtract, these terms come out. So this is 3x minus 3, and it's plus 3, which becomes 3x minus 3. We get a remainder of 0, which we knew was going to happen because f of 1 equals 0. Yes?
So is that why you picked x minus 1? Because you wanted there not to be a remainder? Or?
Right. So that means that I can write x cubed plus 2x squared minus 3 as x minus 1 times q of x, which is x squared plus 3x plus 3. Any other roots of this polynomial of degree 3 are also roots of this polynomial of degree 2. So if necessary, then we can use the quadratic formula to find others. Yes?
So you got x take away 1 is because that's x take away a on the special cases, or I'm just wondering how you got the x take away 1.
X minus 1?
Yes.
Why use that?
Yeah.
Because I look at this particular equation, and I chose it with a little care. I wrote f of x equals x cubed plus 2x squared minus 3, and I did it in such a way so that I could recognize that if I replace x by 1, I get 0.
Okay.
Right? In general, and this is an important idea, a cubic, a quadratic equation looks like a parabola. A cubic equation has the following general form. We'll make use of this in just a moment. Here's a polynomial of degree 2. It may look like this, it may look like this, it may look like this. If it looks like this, for example, as a polynomial of degree 2, it never crosses the axis. If it never crosses the axis, that says what about the roots of the polynomial? There are no real roots. Here is another example of a parabola which doesn't cross the axis. Also, no real roots. This one has exactly 2 real roots, two values of x which make this equal to 0. And we could even construct examples where this comes down, touches once, and there's exactly one real root for a parabola. In general, a polynomial of degree 3 looks like this, and can have as many as 3 roots, but they're hard to find. If I can find just one of those, then, and let's assume this is x equals a, then I can divide this polynomial through by x minus a and write it as x minus a times a quadratic equation and use the quadratic formula to find the other two. Yes?
You always use x minus a to separate it out, right? To put it into x squared.
Would I always use x minus a for, to be one of the factors?
Yeah.
Yeah, that's the important special case. If I'm looking at values of x which make the polynomial equal to 0, I'm looking for values of a which make it equal to 0, then I'm using x minus a.